Okay, welcome back to another video, and this one is going to be on Algebra 2 yet again. And this is going to be on functions and piecewise functions. So this is going to be off of my notes because if I don't get the numbers right for a piecewise function, or a regular function for that matter, they won't work out. So, they'll be really hard to solve. Okay, so here's a couple things you need to know. So domain is the x values of a function, or the inputs. So x values go by a couple names, and those are domain or the input. So the x value on a graph, I hope you know that, because if you don't, this is going to be very tough. But so you have your graph, and okay, this is terrible. You have your x, and you have your y, and you probably hear people yelling, but I'm in a soundproof room, and the noise still gets in here. I don't understand why. Okay, but the domain values are right there, and then let's see, the range are the y values, or the outputs. And then, okay, let me get rid of that. Okay, and then the next thing is going to be a relation or a collection of points. So a relation would be you have your graph. Oh my god, they're so loud. You have your graph, seriously. Okay, you have your graph like that, and then you would have okay, come on. And then, okay, yes, right here. And then you have a point here, a point here, a point here, point here, point here. That would be a relation. Okay, so let me now get rid of all that. Okay. And then a function. Function is a relation where I spelled that wrong. A relation where the x's do not repeat. So function, that's what we're learning about today. So that is the main thing you're going to want to know. So all that you don't really need to know. I mean, it's kind of helpful, but what? You may also hear a trumpet. Okay, so a function is a relation where the x's do not repeat. And there's one more thing, and it's a 1-to-1 function. And that is a function where the y's do not repeat. So the x's and the y's both do not repeat. So those are the two things you kind of need to know. And let me lock that. Okay. So people may ask you, your teacher may ask you, is this a function? And then they'll draw a table. And they'll have that, and they'll have that. And they have their x and the y. I don't know what that is. So they'll say, there's a 1 there, and a 4 there, and a 2, and a 7, and a 4, and a 4. And they'll say, is it a function? And is it 1-to-1? So you would say, okay, let's see, did any of the x's ever repeat? Well, 1, 2, and 4, so no. So it is a function. And you say, okay, is it a 1-to-1 function? So the y's can't repeat. So let's see, 4, 7, and 4. Well, the 4's repeat, so not a 1-to-1 function. So you'll get a problem like that. Okay, yeah, you probably hear the trumpet because, oh my god, that's loud. She is in a soundproof room and I'm in a soundproof room. I don't know how to say it. Okay, but anyway, so they'll ask you a question like that. And sometimes they will show you something like this. Actually, let me just... Oh my god. Come on. Okay. Show you something like this, and I'll use the grid here. 1, 2, 3, 4, 5, 6, 7, 8. There. 1, 2, 3, 4. Down there. Okay, that's 1 too low. Okay, there we go. So, I don't know. Okay, so there's your thing, and they'll show you something that looks like this, maybe. And this is off my notes. They'll show you a parabola, like that. You don't need to know what a parabola is. And they'll say, is it a 1-to-1? Is it a function? And is it a 1-to-1 function? So, there's another way you can do this, and this is with the vertical line test. So, a relation where the x's do not repeat. So that means you draw a vertical line to see if they repeat. So, if you draw a vertical line, so I'm just going to do a dotted one so you know it's not part of it, and it anywhere on the graph, and it doesn't cross an x point more than once. If it doesn't cross the line more than once, then you're fine. Then it's a function. So this one is a function, so good. But it also asked, is it a 1-to-1 function? So you draw a horizontal line anywhere on the graph, and if it crosses the line more than once, the y's repeat, and so it's not a 1-to-1 function. And you can see here, it passes the same y twice, so it's not a 1-to-1 function. So that means that is a function, not a 1-to-1 function. So there's that example. And okay. So let's get rid of that. And let's see. Let's erase that. Oh, wow, that's actually kind of cool. Okay, so let's say they give you something like this. Okay, that was terrible. Wait, there's a straight line. Oh my god. Okay, so it's a straight line like that, maybe. So they show you a line like that, and they say, is it a function? Is it a 1-to-1 function? So again, you do your vertical line test, and you test it, and okay, so it is a function. And then you do your horizontal line test, and look at that, it only crosses it once. So that means it is a 1-to-1 and a regular function. Okay. So that's all good and well. Now let me get rid of all this. Okay, there we go. That's all gone. And now the piecewise functions. But there's one last thing you have to know. And that is when you see, so you should be familiar with this. So y equals mx plus b is the equation of a line. If you see something like this, if you see that f of x, that f parentheses x is pronounced f of x is equal to mx plus b, that's the same thing. F of x is just a fancy way of saying y. But when you see something like this, g of x is equal to mx plus b. G of x is still y, but it's a different line. So it's kind of like on your graphing calculator, y1 and y2 are different y's. So you could also write it as f of x and g of x. Okay? So that makes sense. Okay. So, piecewise functions. So let me find one that is pretty easy. Okay, let's go with this one. So you see something like f of x is equal to, and then you see this thing. No, it's not that simple. It's no. Oh my god, I don't know. You see piecewise function symbol. Okay, let's see. I need the symbol. Yes, this thing. Okay, we're just gonna use the other thing. So let's say you see something like this. So f of x is equal to, and then that little squiggly thing. It actually looks like no, come on, pen. It's that thing. Okay, so f of x. No, okay, yes. So f of x is equal to 2x plus 5 if x is smaller than 2. And then, go over some. You have another one. And it says negative x minus 7 if x is greater than 2. Okay, so you see a problem like this, and you are very confused. So let's zoom out some and move over some. Okay. 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 Let's see here. Okay, no. Nope. Ignore that. Okay. So instead, do f of x is equal to, and then the curly bracket thing, negative 3 if x is smaller than or equal to negative 1, and 2 if x is greater than negative 1. Okay, see, at that problem, okay, so let's draw a graph with our lines. And we'll start right here. So we go down 1, 2, 3, 4, 5. There we go. And then we just draw our line like right there. Okay. There we go. So each of these grid things, these tiny little dots, I don't know if you can see them. like those things, is a unit. So, okay, so you see it's all -1 if x is smaller than or equal to -1, if x is bigger than -1. So what you want to do is you want to draw a dotted line right there at -1. And this is going to be kind of your barrier. You have your dotted line at -1. And then, so you have your line. So y is equal to -3. So y is equal to -3. If x is smaller than or equal to. So smaller than is going to be to the left of this dotted line, and greater than is going to be to the right. But no line will cross over the left and the right. That's the whole idea of a piecewise function. So let's say y is equal to -3. It's not going to cross, so it's smaller than, so it's going to be to the left. So that line will not go to the right of this imaginary line at -1. So let me show you this. So y is equal to -3. So when you graph that, you have a point at -3. So let me take a circle here. So you have, no. So you have a point at -3 right here. And then, so it has a slope of 0, so it just goes straight. Oh my god, that was terrible. So, take it from here, and it goes this way. Goes just like this. Just like that, and it doesn't go to the right because that's the idea of a piecewise function. It doesn't cross both sides of this line at -1. So, let's recap. So they are both, the inequalities both have to do with -1. So I draw my little line at -1. And then I have a line at I have a point at -3 and a line going to the left of it because it's smaller than. But there's one thing to note, and that is that it's smaller than or equal to -1, so this should be a closed circle. Closed circle, like that. And so it only goes to the left because it's smaller than. So let's draw this next one at 2. So you have a point here, and it's bigger than -1, so it goes this direction. Okay, that was terrible. Let's take our line tool out. Okay, so it goes this direction, like this. So this is your completed piecewise function. You have your imaginary line, and if you want, you can get rid of it. It really doesn't matter. But I'll just get rid of it. So you have your okay. So this is the completed piecewise function of f of x is equal to -3 if x is smaller than or equal to -1, and 2 if x is bigger than -1. So, yeah, there's that. So let's try a harder one. So get rid of all of that and change up the text. Okay, so f of x is equal to -x plus 1 is equal to -x plus 1 if x is smaller than 0 and 3x minus 2 if x is greater than or equal to 0. So, let's start with drawing our line. So, since they're both at 0, we draw our imaginary line at 0, but, there's already a line there, so you don't need to draw anything. So now we have to graph our line. So y is equal to okay, let me do this. So y is equal to negative x plus 1, and y is equal to 3x minus 2. So let's start with this one, negative x plus 1. So you have a slope of negative 1 over 1, so you go down 1 to the right one, down 1 to the right one, down 1 to the right one, over and over and over. And you start at y equals 1. So I have my pen tool, and I have a point right here. And so this one is smaller than 0. So smaller than 0, so it can only go to the left of the y-axis. So let's go down 1 to the right one. So you have a point right here. But wait, that's to the right. So there's a problem. So what you do instead is you can invert this slope so that it's 1 over negative 1. And it's still the same thing. So instead you go up 1 to the left 1. So you have a point right here to the left of the y-axis. And so now it works. Up 1 to the left 1. So there is your first line. And this is just smaller than, so you don't need a closed circle. So there is your first line. And so this is a little bit more complicated because they're now lines and they have a slope. So the next one is going to be y equals 3x minus 2. So we have a point at negative 2, which is right here. And this is greater than or equal to, so it's a closed circle. And let me make that an actual circle. Okay, good enough. And then, so you have a slope of 3 over 1. So you go up 1, 2, 3 over 1, all the way up here. And then 1, 2, 3 over 1. So you're all the way up here. So there's your 2 points. And now you just connect them. And you get something that looks like this. So this is the completed piecewise function for f of x is equal to negative x plus 1 if x is smaller than 0, and 3x minus 2 if x is greater than or equal to 0. So, makes sense. Let's just make this one last step harder, and then you'll be done, because I know this is painful, and you really don't like it. Okay, so I'm going to skip the f of x and the curly brackets. So negative 3x plus 4 if x is greater than or equal to 1, and 2x plus 1 if x is smaller than 1. Okay, so let's start this off by drawing our imaginary line. So it's at 1. So right here. Okay, right there. Let's start off with our first line. So it's greater than or equal to, so it's going to be to the right with a closed circle. And we start at point 4, which 1, 2. Okay, we're going to assume right at the top is a point 4 because I don't have enough room. So right at the top is point 4. So we draw a point right there, and it's going to be a closed circle on the line. So we go down 3. So 1, 2, 3. So about here, and over 1. So to about here. So that works out. And we don't need to draw a second point. It's not really necessary. So you have a point right there. So you have a point right there. So that's your first line, and it makes sense. So let's go to your second line with, okay, so 2x plus 1 if x is smaller than 1, so it's going to be to the left with an open circle. So 2x plus 1. So that's right here. Oh, that's not an open circle. That's right there. But that's not on the line. So what you have to do is you have to use your slope and you have to get up there. So up 2 over 1. Right there. So this can now be a closed circle. And you can draw your line from there to there. Wait. Ooh. Ah, nope, I'm wrong. Get rid of all those points. Wait. Huh? I am very confused right now. I'm looking through my notes. I don't understand what I did. And I'm not getting in triple piecewise today because those are a pain. How is that correct? Did I copy it down wrong? I don't know what I did wrong. So I'm going to assume that that is right. I don't see what I did wrong. So I'm going to assume that that is right. And that's your completed piecewise function. I see. The line has to be going up because of the slope. So I'll show you a point right here. Your slope needs to be inverted, I guess. So I don't know. I'm going to go with that's right. I think it is. So that's your piecewise function for this one, I believe. Okay, hopefully that made somewhat sense to most people. And yeah, thank you for watching. If you enjoyed the video, please consider liking and subscribing if you really enjoyed it. But thank you for watching. And yeah, that's it for this video. So good.